So my topic for this today is application of Vedic mathematics sutras in counting shapes. I'm sure you would have gone through a lot of questions in IAVM like this, how many rectangles of all types are in this grid. But in my paper, I'm just trying to decode the sutras and also how many shapes with respect to each size. That's what I'm going to talk about today. So the Vedic mathematics sutras involved here are several. So let me just say about it. Vilokhanam, then Ekadikena Purvena, Paravatya Yojayet, which is my favorite sutra, and all my 3 research papers so far has had transpose and apply in it. This has vertically and crosswise and proportionately and also by elimination and retention. So today I'm going to talk about 2 scenarios. The first one is equal number of rows and columns in a rectangle. So in this is a 2 row and 2 column rectangle. So R is denoting the row and C is denoting the column. Just to be sure that all my slides will have R and C in it, so don't get confused. So in this rectangle, it has got 4 sizes of rectangles. So 1 row into 1 column, 2 row into 1 column, and 2 row into 1 column vertical, and then 2 row into 2 columns. So there are basically 4 sizes in this rectangle that we have to identify. And this gave me the idea, looking at this gave me the idea that there is a vertically and crosswise sutra and also transpose and adjust sutra involved in it. So to find the number of rectangles per size, I'm just using 12 times 12. So the 1 and 2 above denotes the column, the 1 and 2 below denotes the row. So I'm just putting it as in the vertically and crosswise, how we multiply 12 times 12. I just do that. Just one second, I'm just taking my... So I get the answer. 1 times 1 is 1. 1 times 2 is 2, and 1 times 2 is 2. That is 4 when you look into the vertically and crosswise, but I'm going to split it for this purpose. And 2 times 2 is 4. And if you see the number of boxes for 1 times 1 rectangle in a 2 row, 2 column scenario, the number of boxes will be 4. And for 2 row into 2 column rectangle, the number of boxes is just 1. And for the middle one, it is just 2 and 2. So I felt that there is a transpose in this, and it is exactly happening. And this I just converted to a multiplication matrix, 1, 2, and 1, 2, the row and the column. So you can see that 1 times 1 is 1, 1 times 2 is 2, 2 row into 1 column is 2, that gives 2 rectangles, and 2 into 2 is 4. It's like, look, going back to the multiplication table basics. And what I see is like, you can just use the Vedic vertically and crosswise sutra here. If you want to multiply 12 times 12, it is 144. But if I want to see the number of rectangles, I just have to retain the 4 as 2 and 2 in the middle. So I just transpose this multiplication table. I'm going to just transpose it and then write it backwards. And you can see that it is a transposed rectangle. For 1 times 1, it is 4. And 1 times 1, 1 times 1 row and 2 column, it is 2 rectangles. 2 row into 1 column, it is 2 rectangles. 2 row into 2 is 1 rectangle. So you can just see how the numbers are transposed totally. On looking into a closer look, looking at this and just trying to connect it further, I just see the size of rectangle is basically transposing with the 2 row into 2 column, right? And here again, the size 1 row into 2 column is transposing with 2 row into 1 column. So this gave me some idea further looking into it. I was just looking into it and I saw that 1 row into 1 column is transposing with 2 row into 2 column. And when I looked into the total of the row and the column, I was just adding them. 1 row and 2 row was giving me 3 row, and 1 column and 2 column was giving me 3 again. Okay, so that led to me a further note on Ekadikena Purvena. The number of rows is 2. The number of column is 2 in this grid, 2 row into 2 column rectangle. What I did was I was just trying to do by 1 more than here to find the transposition. So 1 row into 1 column, I was able to transpose with 2 row by 1 more than. I was just making the total as 3 for both. And then I was finding the total for 1 row into 1 column. It was the answer of 2 row into 2 column. And for 2 row into 2 column, the answer was 1 row into 1 column. That was exactly transposing. Okay, so this made me feel that it was easy to find the size of any big grid further on. So just one more example to be clear. So I'm going to add it. So I'm going to go through 3 row into 3 column rectangle. So there are basically 9 sizes of rectangle. 3 into 3 is 9 sizes of rectangle. So I'm just showing you how it looks, all the sizes. And I have put the vertical in crossways, and you can see the numbers here. 1 row into 1 column is 1 column into 2 row, and 1 row into 2 column. So these are exactly transposing per se. And you can just see I have not added these numbers as in vertically crossways sutra. I've just put it just as they are. So just putting the same numbers into the matrix, the multiplication table matrix. I'm just getting this 1, 2, 3, 2, 4, 6, and you can see the proportionality sutra here. It's nothing but the multiplication table I have done. And when I looked into the numbers that were transposing, I could see that they were looking like the 2 triangles just transposing. So this is the transpose rectangle. I've just reversed the transpose the numbers, and you can see how they have transposed eventually into 2 triangles. The colors, I've given the colors just to show that it has transposed. The middle one, because this is an odd grid, the middle one doesn't transpose. So you can see that 4 still remains at the same place. So I just try to again see the patterns, the numbers into what they have transposed. I could see that 1 row into 1 column was transposing with 2 into 3 row into 3 column. And if you observe all the numbers that have transposed, you could just see the total of the row was 4, and here also it was 4. So here also it is 4, and here also it was 4. So here also it was 4, and here also it was adding to 4. So that showed that there is a Ekadikena Purvena Sutra by 1 more than for the rows and the column. So here the row is 3 and the column is 3. So you could just see how they have transposed using this sutra, 3 sutras, basically vertically crosswise, transpose and adjust, and the Ekadikena Purvena is in play in identifying the rectangles for the sizes. So rows and columns are different. So here I have a 2 row and a 3 column rectangle. So basically there are 6 sizes of rectangles to identify. And how do I do that? Same way I'm going to do, instead of I just use moving multiplier method, as we know. So it has got 1 times 1 is 1, and you can see the patterns mirroring. So 1 row into 2 column, the top one is the column and the bottom one is the row. So 1 row into 2 column, and you can see the pattern mirroring here. So it transposes with the 2 column into 2 row. So here again, the 1 column into 2 row transposing with the 1 column into 3 row. So I just put the same information into a multiplication matrix here. I take the row 1, 2, and the column is 1, 2, 3. So I have the same numbers, multiplication table appearing here. So 1 into 1, 1 into 2, 1 into 3, and then 2 table has got 2, 4, 6 in play. So now I'm just going to transpose the same numbers, and I see that there is a transposition happening, and I just see some relation again with the Ekadikena Purvena Sutra. So 1 row into 1 column is transposing with 2 row into 3 column, and I observe that they add to 3 and 4 because the one more than for the column is 4 because the columns were 3, and for the rows they were 2 columns, so by 2 rows, so one more than is 3 rows basically. So I could see the same kind of transposition happening. So 1 row into 2 column is transposing with 2 row into 2 column, and the numbers are transposing. So 2 row into 1 column, again, the total is 3 row. And then here you get a total of 4. And 2 row into 1 column has 3 rectangles, and 1 row into 3 column has got 2 rectangles in number. So 1 row into 1 column has got again 6, and 2 row into 3 column has got 1. So you can see number of rows is 2. So by 1 more than 4 rows is 3. And number of columns 3. So by 1 more than 4 columns is 4. So this is the Olympiad question which James had put. So 3 row and 7 column. So the number of rectangles are 168. So I would like someone to ask me questions so I can explain. So anyone, any person ready to ask? No one? Anyone? Any grid you want to ask?
I don't understand Ramya right now. Maybe you can go ahead and start explaining.
Okay.
So, okay, go ahead. Somebody's.
So 1 row into, yes.
I thought somebody was, but I don't think so. Go ahead.
Okay, 1 row into 5 column. How many rectangles are there in this? Okay, that's the question I would like to ask. And I would like to show that 1 row into 5 column, because it is row is 3 here. So by 1 more than is 4. So I make 3 row, and then the number of column is 5. So there are number of columns is 7 here. So by 1 more than is 8. So I make it as 3 column. So basically 1 row and 5 column is 9, transposing with that number, and 3 row into 3 column is 5. Yeah. So this is how we find out the number of rectangles using the transpose Ekadikena Purvena. Anyone wants to try one more? I just like to show one more. So 2 row into 2 column.
Sorry, Ramya, could you go through that again?
Yeah, I will do the other example. 2 row into 2 column grid. Okay, so the number of columns in this scenario is 7. By 1 more than is 1, so it becomes 8. The number of rows is 3, so by 1 more than is 4. Okay, so now I have a question: how many 2 row into 2 column rectangles are here in this grid? Okay, so what I do is I just have to find the complement or the partner for this. So my total should be 4 here, the row, and the column should be 8. So what I do is I just put 2 row into 6 column. So my answer is basically 2 row into 6 column. 2 row into 2 column is transposing with the answer of 2 row into 6 column. So that is 2 row into 6 is 12. And for 2 row into 6 column, it is 4. The number of rectangles for 2 row into 2 column is 12, and 2 row into 6 column is 4. So you can try that. So I can show you 2 row into 2 column. I have 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I didn't do any calculation much. I just tried to connect all the sutras here. Any doubts? Sorry.
Yeah, request if you can explain how we got 4 and 12 in the end.
Okay, so it is basically transposing the 2 row into 2 column grid. I'm just trying to find out how it has transposed, right? So I'm just going to find out using the Ekadikena Sutra here. So I'm just saying the number of rows is by 1 more than is 4. So there are 3 rows. I got 4 rows here. By 1 more than is 4. So I'm just trying to write here the balance here, 2 row here. And for the columns, there are actually 7 columns. By 1 more than is 8. So I'm just writing the balance is 6 column. So 2 row into 2 column will be the answer of 2 row into 6 column. And 2 row into 6 column will have the answer of 2 row into 2 column.
So from there, how do you get to the answer 168?
Okay, so it's just nothing but the so for that you have the triangular numbers, right? Concept. So I'm just trying to do this one. But if you add all the numbers in the multiplication table, it adds to 168.
I see. Okay.
Yeah. So you have 1 to 7 is 28 plus 56. This is 84. And again 84, it is 168. So 1 to 7 is, if you just do the multiplication table, 1 to 7 is 28, then 2 to 14 it is 56, and then 3 to 21 is 84. So totally, if you add, it is 168.
Can we use combinations?
Combinations of what, Srinivasaji?
No, with 7 and 3, can we use combinations like 7C3, 7C2, something like that? Is there a possibility?
Oh, you want to do another one?
No. I'm saying, like, combinations, we can, permutations and combinations we have, right?
Yeah.
Yeah, I think probably, can we use the combinations in this case?
I've not explored in that still,
Okay.
but I think
I'm
there should
just
be possibilities.
yeah, just
I think I've just tried 3 scenarios with this. It is working, so maybe a little more exploration should give more. It should be possible. Yeah.
Yeah, just giving a thought. Even I didn't explore that. Okay.
So this is just multiplication table and reversing and connecting the things. So I finished my presentation with a nice code. This is how it will look. This is what I have tried to do for solution of each rectangle. Only the middle one, the 8, it won't transpose. The rest all will transpose, and you can find the rectangle per size. So I have showed it in the solution. So probably can have this slide later. So just finishing with a nice quote, creativity is just connecting things, by Steve Jobs. Thank you, everyone. Thank you.
Thank you.
Thank you, Ramya. Thank you so